Hello students and good morning. So now I am doing class for class 12. The topic is the same topic that we were doing in the last online class, that is functions. So today also we'll do functions, but we will do some problems from higher secondary question papers. So after I finish these problems on functions, then we will start invertible functions. Okay. So let's start this question now. This is from higher secondary 2015 and this question carries 4 marks. Okay, so this is the problem from composition of functions, right? So this is higher secondary 2015. So question number 2a, number 1 is, let the function f maps. It is read as f maps real to real number, or you may read it as f such that real to real number. R means real number, right? And there is another function, that is the second function, g maps r to r, or g such that real to real number. And there is the third function, h such that real to real number, or it is read as h maps real to real number, be defined by, so this f function is defined by f of x is equal to cos x. And then this function g is defined as g of x is equal to 2x plus 1. And this function h is defined as h of x is equal to x cubed minus x minus 6. Okay. So you have to find out the mapping. Mapping means you have to find out the function. Mapping and function have got the same meaning. Okay. The mapping ko orko word चाहिँ के हो? Function हो. ठीक छ? So find the function or mapping HO within bracket GOF, GOF, GOF. This is the combination of 3 functions out here. Okay. And hence you have to find out the value of HO, GOF of f of x when x is equal to pi by 3 and x is equal to 2 pi by 3. So now first of all you have to find out this mapping HO, GO of f. That means you have to find out HO, GO of f of x. First you find out. And after that you can do the second part. You can find out the value for this HOGO of GOF of fx when x is equal to pi by 3 and x is equal to 2 pi by 3. Okay, and this is the question from, so this is not f of x, it should be HOGO of f of x, HO within bracket GOF of x. Okay, so this is the question from this HS 2015. Okay, so now let's do this question. Now first of all you have to find out the mapping or function HO within bracket GOF. Let us find it. So therefore HO within bracket GOF, this means you have to find out within bracket HO within bracket GOF, first bracket close, again first bracket is closed, and then you write x out here. Is that clear? Next it is simplified as HO. अब यसलाई फेरि हामी bracket भित्र हाल्छौं. H, this is converted into bracket. यो जुन चाहिँ bracket को बाहिर O छ यसलाई हामी के लेख्छौं? Bracket. Then again within bracket GOF, then what do we write here? GOFX. Is that clear? So which is equal to, again it is h of within bracket g within bracket, again यो O लाई हामी फेरि bracket लेख्छौं. ठीक छ? So f of x फेरि bracket close, this bracket is closed, again this bracket is closed. So I think you have understood it. Okay. Now first of all you will put the value for f of x. What is the value for f of x? It is cos x. Okay. So is equal to h within bracket z, again within bracket, instead of f of x what can we write? It is cos x. Okay. अब हामी यहाँ cos x हाल्छौं. अब यो g of x फर्ममा आयो. So what is the value for g of x? It is 2x plus 1, right? The x को जग्गामा यहाँ cos x छ भने g of cos x कति हुन्छ? 2 cos x plus 1. Clear? So write down. So is equal to h within bracket. What is g of cos x? If it is g of x is equal to 2x plus 1. So what is g of cos x? It is 2 cos x plus 1, right? So it is 2 cos x plus 1. So I think you have understood it, okay? So now which is equal to, now this is just like your h within bracket x, but in the question, what is the value for h within bracket x? It is x cube minus x minus 6. So instead of x, there is 2x plus 1, right? So instead of x, there is 2x plus 1. So instead of x, if you write 2 cos x plus 1, this right hand side becomes, it is 2 cos x plus 1 whole cube minus, again what is x? Put it within bracket, 2 cos x plus 1. Is that clear? Then write down minus 6. So I think you have understood it, okay? So let's simplify it further, right? You know, this is your a plus b whole cube. What is the formula? A cube plus 3a square b plus 3ab square plus b cube. You should know this formula. What is a whole cube? 2 cos x whole cube, that is your a cube, plus 3 into a square, 2 cos x whole square into b is 1, that is your 3a square b, plus 3, what is a? 2 cos x, and what is b whole square? It is 1 whole square, plus b whole cube, isn't it? You know the formula a plus b whole cube. तिम्रो सबैलाई a plus b whole cube थाहा छँदैछ हैन? त a plus b whole cube भनेको नै a cube plus 3a square b plus 3ab square plus b cube, right? So plus अब हामी के लेख्छौं? 1 whole cube लेख्छौं. So I think you have understood it. This is the place for a and this is the place for b. So it is a cube plus 3a square b plus 3ab square plus b cube. Okay? So next simplify this expression. Minus 2 cos x minus into plus minus 1, and this is your minus 6, right? This is your minus 6. Minus 1 minus 6. Is that clear? So which is equal to, now let us simplify it now. What is 2 whole cube? 8. This is cos cube x, okay? Plus what is 2 whole square? 4. 4 3s are 12. This is cos square x, plus next 1 whole square is 1, multiply by 3, multiply by 2 cos x. What did we get now? We get, what do we get? It is 6 cos x. Then write down, this is plus 1 minus 2 cos x minus 1 minus 6. Okay? Next, you can cancel this, plus 1 minus 1 gets cancels. So which is equal to, this is 8 cos cube x plus 12 cos square x, right? So it is 8 cos cube x, this is 12 cos square x. Next, 6 cos x minus 2 cos x, what is that? Plus 4 cos x plus 4 cos x, then write down minus 6. So this is the mapping HO within bracket GOF. This is the function, okay? The value of this function is this one. So this is the final answer. So I think you have understood it. So you can copy it. So this is the answer for the first part. That is, we have found out HO within bracket GOF. This is the function, okay? Next, you have to find out the value of this function of x when x is equal to pi by 3 and x is equal to 2 pi by 3. So now we will use this first part to find out the second part of the equation, okay? So we can copy it. So now let's do the second part. So let's do the second part now. So here, this expression is the value of the function, that is HO within bracket GOF of x, which is equal to this one, 8 cos cube x, 8 cos cube x plus 12 cos square x plus 4 cos x minus 6. Okay, so now you have to get its value when x is equal to pi by 3. So when x is equal to pi by 3, okay, so therefore within bracket HO within bracket GOF of pi by 3, now instead of x you put pi by 3, so it is 8 cos cube pi by 3 plus 12 cos square. This is pi by 3 plus 4 cos pi by 3 minus 6. Okay, so now let's get its value now. Let's find out the value of this expression. So instead of x we put pi by 3. Okay, so which is equal to 8 within bracket. What is cos pi by 3? Pi by 3 is, you know that it is 60 degree. What is the value for cos 60 degree? It is half. So this is half whole cube plus 12 into, again it is cos 60 half whole square plus 4 into half, and this is minus 6. Is that clear? Now you can simplify it further. 8 into 1 by 8 plus 12 into 1 by 4 plus this is 2 minus 6. So 8 here gets cancels. 4 1s are 4, 4 3s are 12, which is equal to 1 plus 3. This is 1 plus 3, and this is plus 2 minus 6 is minus 4, isn't it? Plus 2 minus 6 is minus 4, which is equal to 4 minus 4 is equal to 0. So this is the answer. So what is the value for HO within bracket GOF of x when x is equal to pi by 3? Its value is 0. So that is your answer. Okay. So one of the answers is 0. So I think you have understood it. Just you have to put the value for x in this expression. That is x is equal to pi by 3. Now similarly, you have to get the value of this function of x when x is equal to 2 pi by 3. You first copy it, note it down. So अब हामी अर्को पोर्सन गर्छौं, that is you have to get the value of this function of x when x is equal to 2 pi by 3. त हामी यही फंक्सन ले लेख्छौं अघि निकालेको हैन, यो त अघि हामीले निकालेको हो नि त. सो अब हामी लेख्छौं putting x is equal to or when x is equal to, so अब हामी के लेख्छौं putting x is equal to 2 pi by 3 in this function, putting x is equal to 2 pi by 3. Okay, so therefore this is HO within bracket GOF of this is your 2 pi by 3 is equal to 8 cos cube 2 pi by 3 plus 12 cos square 2 pi by 3 plus 4 cos 2 pi by 3 minus 6. So I think you know how to get the value for cos 2 pi by 3. So यो cos 2 pi by 3 को value हामी कसरी निकाल्छौं तिमीहरु सबैलाई थाहा भएकै कुरा हो यो. You have done it in class 11. That is cos, त रफमा हामी निकालौं यसको value. 2 pi by 3 भनेको कति हो? Pi by 3 is 60 degree, you know that. 180 degree by 3 is 60 degree. 60 into 2 is 120. So it is cos 120. So how can you get its value? So 120 can be written as 180 degree minus 60 degree. Okay. So what is the formula for cos 180 minus theta? You know that, minus cos theta. Because in this case 180 minus 60 degree lies in the second quadrant, and in the second quadrant you know that the sign of cos is minus. And since 180 is 90 degree into 2, 180 degree 90 into 2 भएको कारणले गर्दाखेरि, even multiple of 90 भएको कारणले गर्दाखेरि cos remains as it is. Cos change हुँदैन. Cos as it is बस्छ. That means minus cos 60 degree. Okay, so which is equal to minus, what is the value for cos 60 degree? Which is equal to minus half. So what is the value for cos 2 pi by 3? That is cos 120, it is minus half. So let us write here 8 into minus half whole cube plus 12 into minus half whole square plus 4 into minus half minus 6. Is that clear? So which is equal to 8 into minus 1 by 8 plus 12 into 1/4, and this is plus into minus minus, this is 2 minus 6. And so here 8 gets cancels, 4 ones are 4, 4 threes are 12. So this is minus 1 plus 3, and this is your minus 8. That is minus 8, right? So which is equal to, what is minus 1 minus 8? That is your minus 9. Minus 9 plus 3, which is equal to minus 6. So this is the final answer. So we have got the value for HOGOF of x when x is equal to 2 pi by 3. So what is this value now? This is minus 1 plus 3 minus 8. Minus 9 plus 3 is minus 6. That is, your minus 6 is the correct answer. So I think you have understood it. So you can copy it. Now we'll do the next question from HS question paper. Okay. So now we'll do the next question, that is from HS 2016. This question carries 2 marks. The question is 1A number 1. So let capital R be the set of all real numbers, and for all small x belong to the set of real numbers, the mapping f maps real to real number, or it is read as f such that real to real number is defined by f of x is equal to ax plus 2. Now this x belongs to the domain R, and this f of x belongs to the codomain R or range of R. Okay. So now if f of f is equal to IR, what is IR here? IR is known as the identity function on the set of real numbers. Okay. IR भनेपछि के हो? Identity function. So IR is known as what? Identity function. Identity function. So you know about identity function, that is, you can write IR of x is equal to x. This is known as identity function. You know that. You should know this relation. If IR is an identity function, then we can write IR of x is equal to x. Is that clear? So in this case, it is given that if FOF, that is, this is the problem from composition of function, or this is known as composite function. FOF of is equal to IR, that is your identity function. Then you have to find out the value of A. So I think you have understood the question. Okay. So now from this given and f of x is equal to ax plus 2, you have to get the value for A. Okay. So here given is FOF of, you can write x. Now x belongs to the domain R. So FOF of x is equal to, you can write IR of x. Both side हामीले पछाडी के थप्यौ? X domain थप्यौ. X भनेको it belongs to the domain R. Okay. So now this composite function or composition of function is defined as, or this is f of x, which is equal to, what is identity relation? What is identity function of x? That is your x by definition, isn't it? You can write here x. Okay. So, or what is f of this? Now within bracket there is f of x. You can put the value for f of x from given. What is that? This is ax plus 2, which is equal to x. Now again, this is f of x. Instead of x there is x plus 2. Instead of x there is ax plus 2. This is also the form f of x, which is equal to x. Now again you can put the value here. So if f of x is there, then this is x plus 2. But instead of x, you should put x plus 2 here. So what is the value for f of ax plus 2 from the right hand side? It will be a within bracket. Again, instead of this x, you have to put this value, that is ax plus 2. Ax plus 2. Then you should write plus 2. Plus 2, which is equal to x. So I think you have understood it. Okay. So next, or let us simplify it. A into a square x plus 2a, then this is plus 2 is equal to x. Okay. Now in this case, since you have to get the value for a, so let us compare it. Okay. So this is a square x plus this is your 2a plus 2 is equal to x plus 0 is there. This is just an identity. This is just like an identity. So you can equate the coefficient of x and constant term in order to get the value for a. So equating I think you know this identity function. So equating the coefficient of x and constant term. So equating the coefficient of x, equating the coefficient of x and constant terms right? So equating the coefficient of x and constant term from both the sides, what do we get? Here the coefficient of x is 1, here the coefficient of x is a square. So this is a square is equal to 1, and what is the other one? You can equate the constant term here, that is 2a plus 2 is equal to 0. That is, it is 2a plus 2 is equal to 0. So from here we get a is equal to plus minus 1, and from here you get 2a is equal to minus 2, and what is the value for a? A is equal to minus 1. So which is the common value here? A is equal to minus 1. So that is the correct answer. Okay. So the correct answer is a is equal to minus 1. Because a minus 1, here also a minus 1 is common for both these equation, isn't it? So that means what is the value for a? A is equal to minus 1. So this is the correct answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is from HS 2017, and this question is from part B, that is your objective type of questions, and this question carries 1 mark. Okay, so the question is you have to choose the correct answer out here. Okay, so let capital R be the set of real numbers. This is question number 1. Let capital R be the set of real numbers. Real numbers, you know that they are defined numbers, and the mappings f such that real to real number and g such that real to real number be defined by f of x is equal to 5 minus x square and g of x is equal to 3x minus 4. Now you have to find out the value of FOG, fog of minus 1. So you have to choose the correct answer for fog of minus 1 is A, B, C, D ma कुन चाहिँ correct option हो यो चाहिँ हामीले check गर्नुपर्छ. The fog of minus 1 एकैचोटी हामी निकाल्न सक्दैनौं. So this is known as, this is a composite function, composition of functions, right? So in order to get fog of minus 1, first of all you have to get the value for fog of x, right? So let us find out fog of x. That is, therefore FOG fog of x is equal to, it is defined as f of within bracket g of x, right? So which is equal to, now you can put the value of g of x. What is that function g of x? It is 3x minus 4. So f of within bracket you can write 3x minus 4. So now instead of x there is 3x minus 4. This is just like your f of x. So what is the value for f of x? It is 5 minus x square, right? So which is equal to, now instead of x you put 3x minus 4. So this right hand side now becomes 5 minus, what is x whole square? This is your 3x minus 4 whole square. So I think you have understood it. Okay, so this is the value for FOG, fog of x, 5 minus 3x plus 4 whole square. So let us write here, therefore fog of x is equal to 5 minus, this is your 3x minus 4 whole square. So no need of simplifying it. Now you put minus 1 here. You put x is equal to minus 1 here. Therefore, log of minus 1 is equal to 5 minus 3 into minus 1 minus 4. This is your whole square. Okay. So which is equal to 5 minus within bracket minus 3 minus 4 whole square, which is equal to 5 minus within bracket minus 7 whole square, which is equal to 5 minus, what is minus 7 whole square? That is your 49, isn't it? So which is equal to 49. So what is 5 minus 49? So 5 minus 49 is minus 44. So this is the answer. So which is the correct option out here? It is B. B, that is minus 44 is the correct answer. So you can write down here the correct alternative is B, that is minus 44. So I think you have understood it. So you can copy it. Now we'll do the next question. Now we'll do the next question, that is from HS 2019. So this is question number 1. This is also from the objective type of question, and this is from the part B section, and this question carries 1 mark. Okay, so question number 1 is you have to choose the correct answer. So question number 9 is the domain for which the functions f of x is equal to 3x square minus 2x and function g of x is equal to 3 into 3x minus 2 are equal will be. Domain means, what do you mean by domain? So domain means, two sets, that is, this is your A and this is your B. Okay. So this is the function from A to B. Okay. So this is x and this is your f of x. So x belongs to the set A, and this f of x belongs to the set B, right? So x belongs to the set A. This x is known as the domain of A, and this f of x is known as the range of f. That is, x belongs to the set A. This A, that is x, is the domain of f, and this f of x is the range of f. That means domain means you have to get those set of values of x for which these two functions are equal. That means you have to get the values of x for which these two functions are equal. So यसमा हामीलाई के निकाल्नु भनेको, actually x को value निकाल्नु भनेको. You have to get those values of x for which these two functions are equal. So I think you have understood it. Okay. So now let's do it now. So since in the question it is given that f of x is equal to g of x, right? So what does it imply? What is f of x? F of x is 3x square minus 2x, which is equal to, what is g of x? It is 3 into 3x minus 2. Now let us solve it to get the values of x. Okay, so this is 3x square minus 2x is equal to, multiply by 3 here. This is 3 3s are 9x minus 6. Take all the terms to the left hand side. So this is 3x square minus 2x minus 9x plus 6 is equal to 0, right? So, or this is your 3x square, then minus 11x, then plus 6 is equal to 0. Now we can solve it. So let us factorize it by middle term breaking. So 3 6 are 18. If you multiply those two numbers, you should get 18. And since there is plus sign here, so after adding those two numbers, you should get 11. So what are those two numbers? If you multiply them, you will get 18. And if you add them, you should get 11. That is 9 2s are 18. 9 plus 2 is 11, right? So this is 3x square minus within bracket 9 plus 2 into x plus 6, which is equal to 0. Okay. So, or this is your 3x square. Now multiply them. This is minus 9x minus 2x plus 6, which is equal to 0. or here 3x is common, within bracket x minus 3 minus 2 is common. This is x minus 3 which is equal to 0, or this is your x minus 3 into 3x minus 2 is equal to 0. So now you know how to get the values of x. So either first factor is equal to 0 or second factor is equal to 0. That means therefore x is equal to, this will be 3 comma 2 by 3, or it may be, so what are those set of values of x? It is 2 by 3 comma 3. This is 2 by 3 is written first, then after that it is 3. So which is the correct option here? It is 2 by 3 comma 3. So C is the correct option. Now C is the correct option. So I think you have understood it. त तिमीले बुझ्यौ होला यो सजिलै छ हैन त you have to domain भनेको चाहिँ you have to get those values of x for which these two functions f of x and g of x are equal. So equating f of x with g of x, we have got those values of x as 2 by 3 comma 3. Okay, so this C is the correct option. Okay, so now यो function को जति पनि प्रब्लमहरु आएको थियो यो एचएस मा हामीले सबै गर्यौं. अब हामी गर्छौं invertible functions. Now let's do invertible functions now. त पहिला यो तिमीले कपी गरिहाल, you can note it down. So now we will do invertible functions. The functions which can be inverted is known as invertible function. So now what is the meaning of invertible functions? अब हामी बुझ्ने चेष्टा गरौं यो invertible function भनेको चाहिँ के हो? Suppose there is f such that a to b. This is the given function. Okay, so now this is your set A and this is your set B. Your set A ra set B bhayego. ठीक छ? There is a mapping from set A to set B, that is f. That is a function f from set A to set B. So now if there exists a function g such that b to a now. अब उल्टा. अब के भयो? b to a. अब के आउँदैछ? b to a under mapping z or function z. Is that clear? So this is the given function f such that a to b is the given function, and if there exists a function z such that b to a under mapping z, okay, then you have the यसमा चाहिँ के हुन्छ अब g to a from b to a भइगयो. ठीक छ? त यसमा हामी के गर्छौं भन्दाखेरि gof such that के हुँदैछ gof. त gof के भयो भन्दाखेरि यहाँ f चाहिँ के हुँदैछ f maps from a to b and g maps from b to a. त gof it maps from where to where? That is a to a, isn't it? Set a to set a. Set a to set a. That is your identity function. That is your what? Identity function. That is gof. Gof is equal to कति भयो? यसलाई के भन्छ हामी ia भनेर लेख्छौं. The gof is defined as a to a. Gof, that is gof such that a to a. A देखि b मा गयो. यस्तो भयो खासमा. A देखि b मा गयो, फेरि b देखि a मा आयो. त्यसले gof भनेको के भयो? a to फेरि a भइगयो. Gof भनेपछि के भयो? a to a. Right? Is that clear? Gof such that a to a. So a to a means this is the identity function, or you may represent it by gof is equal to ia. Similarly, what is fog? So similarly, what is fog? FOG fog. Fog के भयो अब? FOG fog के भयो? अब गर्दा चाहिँ के भयो? b देखि a मा आयो, फेरि a देखि b मा गयो. पहिला हामी g लिन्छौं. b देखि a मा गयो, पहिला हामी के लिन्छौं? g लिनुपर्छ है जहिले पनि. That is domain of fog is equal to domain of z, and domain of gof is equal to domain of f. त्यही कारण हामीले domain of f निकाल्यौं, a to b from b to a. So it is a to a. Fog means Domain of fog is equal to domain of Z. Domain of Z कुन चाहिँ हो? B. What is range of Z? This is A. Just उल्टा भएको. Domain of F is A and range of F is B. Now it is just the invertible function. Z is the invertible function here, right? So what is the domain of Z? This is B. And what is the range of Z? This is A. The fog के भयो अब? B to A, B to A to B. That means it is B to B. This is also an identity function, right? So therefore this fog can be represented by IB. So fog can be represented by IB. Is that clear? This is fog is also an identity function. So in this case, let f such that, so how will you define invertible function? Let f such that A to B be the given function. If there exists a function g such that B to A, if there exists a function g maps from B to A such that GOF is equal to IA and fog is equal to IB, then this is known as invertible function. Then there exists an invertible function. There exists an invertible function, and this g is known as what? And this g is known as the inverse of f, and it is written as f inverse is equal to z. So I think you have understood it. So this is the definition of invertible function. So you first note it down. यसलाई नोट गर्नु तिमीले. अब हामी डेफिनेसन लेख्छौं. इन्भर्टिबल फंक्शन को अब हामी डेफिनेसन लेख्छौं. ठीक छ? So now let us write down the definition of inverse function. So now अब हामी यहाँ जुन चाहिँ मैले अहिले भक्क एक्सप्लेन गरे यसलाई नै हामी मिलाएर लेख्छौं. That is the definition of invertible function. So let us write down the definition of invertible function. Okay? So now definition. So definition is let f such that A to B, let f such that A to B be a given function, be a given function. Let f such that A to B be a given function if there exists a function, if there exists a function g such that now B to A, this means that this A is the domain of f and B is the codomain or range of f. Here B is the domain of z and A is the range or codomain of z, and there exists a function g maps from B to A such that GOF is equal to IA and fog is equal to IB, or you may write it as IX also, because we always write X belongs to the set A and Y belongs to the set B, isn't it? त तिमीले IA को जग्गामा IX लेख्दा पनि हुन्छ है. ठीक छ? किनभने we always put X belongs to the set A. ठीक छ? कोही बेला IA नलेखेर हामी IX पनि लेख्न सक्छौं. त don't get confused. Okay? Don't get confused regarding this one. IA is equal to IX लेख्दा पनि भयो किनभने X belongs to the set A. अनि कोही बेला हामी IB मा हामी के लेख्छौं? IY पनि लेख्छौं किनभने Y belongs to the set B. Okay? अनि Y लाई हामी के पनि लेख्छौं अरे Y is equal to f of x पनि लेख्छौं. ठीक छ? बुझ्दैछ सबैले? So I think you have understood it. We may take IA as IX identity function and IB as IY as identity function. Okay? So you can note it down. So, and fog is equal to IB, such that GOF is equal to IA and fog is equal to IB, then F is invertible. Then the function F is invertible. Then the function F is invertible, and G is called the inverse of F. G is called the inverse of F, and is written as we can write it as F inverse is equal to Z. So here in this case G is known as the inverse of F, and we write it as F inverse is equal to Z. So therefore तो यो G को जग्गामा हामी के लेख्न सक्छौं, F inverse लेख्न सक्छौं. That is F inverse OF is equal to IA and what? Instead of G we can write F inverse. Okay, so now G means F inverse is equal to IB. That is F inverse OF is equal to IA, identity function, and FOF inverse is equal to IB, that is your also identity function. So this is the definition of invertible functions. So अघि नै मैले तिमीलाई भनिसकेको छु यो डायग्राम हैन, यो डायग्राम फेरि म अझै एक्सप्लेन गर्दैछु. So A, this is the set A. Okay, this is the set A and this is the set B, and this is the function F from A to B. Okay, and this X belongs to the set A and F of X belongs to the set B. Okay, now there exists a function G such that from B to A. Okay, from B to A. Now here Y belongs to the set B, and this is your G of Y belongs to the set A. This is the inverse function. In this case, F such that A to B, right? Just try to understand it. You जुन चाहिँ म diagram बनाउँदैछु, you just try to understand it. Okay, so F such that A to B, here X belongs to the set A, X belongs to the set A. So now here Y belongs to the set B, or you may write F of X belongs to the set B. Okay, that is you can write it as Y is equal to F of X. This is for the function F. Okay, for the function Z, G such that this is from B to A. Okay, now here Y belongs to the set B, Y belongs to the set B, Y belongs to the set B, and X belongs to the set A. That is Y belongs to the set B and X belongs to the set A. Or you can write here ZY belongs to the set A, or you may write X is equal to Z of Y, or you may write X is equal to Z of Y. So I think you have understood it. Okay, so तिमीले यो डेफिनेसन चाहिँ यहाँसम्म लेख्नु, यो सारे पनि भयो नसार्दा पनि हुन्छ, or just try to understand it. Okay, so F such that A to B, that means X belongs to the set A and here Y belongs to the set B, or F of X belongs to the set B, so this Y is equal to F of X. So in this case this is the inverse function, G such that B to A, here Y belongs to the set B, so X belongs to the set A, so G of Y belongs to the set A, so X is equal to G of Y. Is that clear? So you can copy it. Now we'll do some theorems now. So now we will do this theorem number 1. So theorem number 1 is, if F such that A to B, or F maps the set A to set B, is 1 1 onto function. If the function f such that a to b is 1 1 onto function, then prove that f is an invertible function. यदि f is a bisective function हो भने 1 1 onto हो भने bisective function भनेर भन्छ त्यसलाई, you know that, isn't it? So if f such that a to b is a bisective function, then you have to prove that f is an invertible function. त अघि हामीले डेफिनेसनमा के सिक्यौ भन्दाखेरि if f such that a to b is a given function, then there exists a function g such that b to a such that f GOF is equal to IA and FOG is equal to IB, then f is invertible. The fog or GOF, हामी यसमा GOF पनि निकाल्नु पर्यो, fog पनि निकाल्नु पर्छ. GOF is equal to IA हुनु पर्यो, fog is equal to IB हुनु पर्यो, अनि मात्रै यो इन्भर्टिबल फंक्सन हुन्छ. पहिला के दिएको छ, is 1 1 onto भनेर दिएको छ. If f such that a to b is 1 1 onto, you know the definition of 1 1 onto, that is distinct elements in the set A should have distinct images in the set B. That is your 1 1 function. Onto को लागि चाहिँ के हुन्छ भन्दाखेरि, त onto को लागि चाहिँ के हुन्छ भन्दाखेरि, each and every element in the set B has at least one pre-image in the set A. प्रत्येक एलिमेन्ट B को प्रत्येक एलिमेन्ट को pre-image चाहिँ set A मा हुनै पर्छ. That is your onto function. That is, if y belongs to the set B, there exists x belongs to the set A such that f of x is equal to y. That is the definition of your onto function. Okay. So now here let us write, here given is, let us do the solution. Let us prove it. Given f such that a to b is 1 1 onto, is 1 1 onto. So let y belongs to the set B. So therefore there exists x belongs to the set A. This is there exists x belongs to the set A such that what can you write? Such that f of x is equal to y. Such that f of x is equal to y. Okay. So now let there exist a function, let there exist a function g such that b to a, such that b to a. Okay, let there exist a function g such that b to a, such that it is b to a, right? Now let in this case y belongs to the set B, and let y belongs to the set B and x belongs to the set A such that g of y is equal to x. So I think you have understood it. Okay. So now let us prove that. That means you have to find, for f to be invertible, you have to find out FOG, fog and GOF. Okay. So therefore FOG of x, let us find out fog of x, which is equal to not fog of x. First you find out GOF of x. Fog को चाहिँ y हुन्छ, किनभने gy छ नि त यहाँ, हैन? त GOF को चाहिँ के हुन्छ? GOF को चाहिँ x, because you know f of x is equal to y. So therefore let us write here GOF of x. Let us find out GOF of x is equal to, what is GOF of x? Is equal to g of f of x. Right? It is defined as, GOF of x is defined as, you know that g within bracket f of x. This is the composition of function, right? So g of, what is f of x? F of x is y. So g of y is equal to whatever x. Is that clear? So this x can be written as IA of x. This is identity function, isn't it? So IA of x, this only x can be written as IA of x. So therefore from here it implies that, GOF of x is equal to IA of x, which implies that the x cancel गरेछ, that is GOF is equal to IA. that is GOF is equal to IA. ठीक छ? त यो f such that a to b is 1 1 onto भएको कारणले गर्दा चाहिँ हामी के लेख्न सक्छौं, let y belongs to the set b, there exists x belongs to the set a such that f of x is equal to y. So let there exists a function g such that b to a. Now in this case अब b देखि a मा आयो, बुझ्यो? यो 1 1 onto भइगयो, a to b 1 1 onto हो भने b to a पनि 1 1 onto नै हुन्छ. g maps b to a is also 1 1 onto. Is that clear? There exists a function g such that b to a is also 1 1 onto. That means let y belongs to the set b and x belongs to the set a such that g of y is equal to x. Is that clear? त यहाँबाट हामीले के निकाल्यौ, GOF is equal to IA. अब fog of y निकालौं. Again fog of y is equal to, it is defined as what? Fog of y is defined as f of g of y, which is equal to f of, what is g of y? G of y here is x, this is x, and what is f of y? F of x? F of x is y, right? So which can be written as IB of y. This is IB of y because y belongs to the set b. Y belongs to the set b भएको कारणले गर्दा पनि IBY लेखेको हो यो. ठीक छ? यसमा पनि since this x belongs to the set a, x belongs to the set a, so that's why written as I capital A of x. त IA लाई अघि नै मैले भने IX पनि लेख्न सकिन्छ, IB लाई IY पनि लेख्दा हुन्छ. बुझ्नु बुझेन? So which implies that fog of y is equal to IB of y, right? So which implies that the y cancel गरेछ त यो, that is fog is equal to IB. So now from the definition of invertible function we can write down that this f is invertible function. So hence f is invertible, hence f is invertible function. So it is proved. So I think you have understood this proof. You can copy it. त घरमा एकपल्ट यसलाई रिभिजन चाहिँ गर्नुपर्छ है तिमीले, एकपल्ट रिभिजन चाहिँ गर्ने. यहाँ जति पनि यो नोटेसहरु ल्याएको छ यो सबै नोटेसहरु तिमीले याद गर्नै पर्छ. In order to do the problems, you have to remember all this. You should know all these notations and all, right? त यसलाई तिमीले घरमा हेर्नै पर्छ यो. So यो theorem चाहिँ के भन्दैछ, if f such that a to b is 1 1 onto, then prove that f is an invertible function. So I have proved that this function f is an invertible function. Okay, so now we will do the converse part. Converse part means if f is an invertible function, then this is 1 1 onto. अब हामी उल्टा प्रुभ गर्छौं. ठीक छ? So now let's do this theorem number 2. So the theorem number 2 is if f such that a to b is an invertible function, then prove that f is 1 1 onto. त अब चाहिँ के दिएको छ भन्दाखेरि यो जुन चाहिँ फंक्सन छ from a to b, it is an invertible function बनाइदिएको छ. You have to prove that f is 1 1 onto. Okay, so now solution. So here given is, given f such that a to b is an invertible function, So from the definition of invertible function, what can you write? There exists a function g such that b to c such that GOF is equal to IA and fog is equal to IB. You know that, isn't it? That is from the definition of invertible function. So therefore there exists a function g such that b to a such that GOF is equal to के हुन्छ? IA or IX, you may write IX, and fog is equal to and what is fog is equal to IB, and fog is equal to IB. So I think you have understood it. Okay, so now you have to prove that f is 1 function. You have to prove that f is, first of all, 1 onto मा पहिला हामी 1 function prove गर्छौं. In order to prove f as 1 function, you have to prove that we have f of x1 is equal to f of x2 implies that f of x1 is equal to f of x2, right? So therefore f of x1 is equal to f of x2. Now prove x1 is equal to x2 now. So or both the sides you can take z of f of x1, both sides हामी के लिँदैछौं, z लिँदैछौं है, f of x2. Is that clear? So you can write it in terms of GOF, that is GOF of x1. GOF of x1 is equal to, this is also GOF of x2. Now since this is f is invertible function, here GOF is equal to IA, that is your identity function. Fog is also identity function. So here you can write GOF, instead of GOF you can write IA of x1, and instead of GOF also this is IA of x2. So this is your identity function, or which implies that x1 is equal to x2, that is x1 is equal to x2. So f of x1 is equal to f of x2, what does it imply? x1 is equal to x2. That means the function f is 1. Therefore the function f is 1. Therefore the function f is 1. So we have proved that the function f is 1. Okay, now we have to prove that f is an onto function. In order to prove that f as an onto function, if y belongs to the set B, there exists x belongs to the set A such that f of x is equal to y. You have to prove it. Okay, now let us assume for onto function, let y belongs to the set B and zy belongs to the set B, and let z of y is equal to x. Is that clear? Now let us find out FOZ of y. Let us find out fog of y. Let us find out fog of y, which is equal to, it is defined as, fog of y is defined as f of z of y, right? So or what is fog here? FOZ, fog, IBY, isn't it? So this is IBY is equal to IBY. This is fog is your identity function. So we can write here IBY. So what is z of y here? It is x. So it is f of x. So you know that IB of y is identity function. You can write y is equal to f of x. Okay. So therefore for each y belongs to the set B, there exists x belongs to the set A such that what? Such that y is equal to f of x. Okay, so therefore the function f is onto. Therefore the function f is what? Therefore the function f is onto. Is that clear? So hence the function f is 1 onto. So you can write here, hence the function f is 1 onto. 1 onto proved. So we have proved both 1 as well as onto. So I think you have understood it. So you can copy it. Now we'll do the next theorem. So now we'll do the next theorem, that is theorem number 3. Prove that an invertible function has a unique inverse. कुनै एउटा invertible function छ जुन चाहिँ invert हुन सक्छ, त्यसको चाहिँ एउटै मात्रै इन्भर्स हुन्छ भनेर प्रुभ गर्नुपर्छ. So if the function is invertible function, then it is automatically 1 1 onto function. Okay, so let f such that a to b be an onto function, 1 1 onto function, be a 1 1 onto function, and hence it is invertible, and hence it is invertible, and hence it is invertible. 1 1 onto function भयो भने त invertible हुन्छ हैन. So if possible, let us assume that, if possible, let us assume that the function f has two inverses, that is g and h, okay. So now you know that f of g, that is f of g is equal to ib. You know that f of g is ib from the definition of inverse, and f of h is also ib. f of h is also ib. I think you have understood it. So you can write here, since iby is equal to iby, both are same, that is for the left hand side you can write f of z of y is equal to f of h of y, right? For this left hand side, ib of y, that is your identity function y, you can write here as f of z of y, and here ib of y, instead of ib you can write f of h of y. So by definition it can be written as f of z of y is equal to, this is f of h of y. I think you have understood it, okay. So which implies that from both the sides you can cancel this f. So what do we get? Z of y is equal to h of y, and from here also z is equal to h. That means g is equal to h means एउटै मात्रै इन्भर्स हुन्छ. So therefore the inverse is unique. That means g is equal to h. हामीले suppose गर्यौं, if possible let us assume that the function f has two inverses, g and h, and we have proved that g is equal to h. So the inverse is unique. That is only one. Therefore the inverse is unique. So hence an invertible function has a unique inverse, proved. त कुनै पनि इन्भर्टिबल फंक्शन को एउटै मात्रै इन्भर्स हुन्छ, not more than one. Okay, so you can copy it. Now we'll do the next theorem. So now we'll do the next theorem, that is theorem number 4. The theorem number 4 is, let f be an invertible function. Then prove that f inverse is equal to f. You have to prove that f inverse is equal to f. Okay. So since let us write, let f such that a to b be an invertible function. So in order to prove that, in order to prove that f inverse is equal to f, it is sufficient to prove that F inverse OF is equal to IA and F OF inverse is equal to IB. It is just like GOF is equal to IA and FOG is equal to IB. So if you can prove that F inverse OF is equal to IA and F OF inverse Y is equal to IB, then we can write down that F inverse is equal to F. So let us write here, in order to prove F inverse is equal to F, comma, it is sufficient to prove that F inverse F is equal to F inverse OF is equal to IA and F OF inverse is equal to IB. Is that clear now? Now here, since F is 1 1 onto function, since F is an invertible function, so it is 1 1 onto. Since F is 1 1 onto function, so its inverse is also 1 1 onto function. Isko inverse pani obviously 1 1 onto function hai huncha. Therefore F inverse is also 1 1 onto. F inverse is also 1 1 onto, right? So let Y belongs to the set B. So there exists X belongs to the set A such that what do we write? F of X is equal to Y. Or you can take F to the right hand side, so it becomes F inverse Y is equal to X. So I think you have understood it. Okay. So next you will prove that, therefore next you will prove that F inverse OF of X, let us get its value. Let us prove F inverse OF is equal to IA. You prove whatever by else. F OF inverse is equal to IB. Okay. So which is equal to F inverse F of X. So I think you have understood it. It is defined as F inverse within bracket F of X, which is equal to F inverse, what is F of X? F of X is Y, which is your, what is F inverse Y? That is your X. Is that clear? So which is equal to, this is your IAX. This is your IAX, because this X belongs to the set A. This X belongs to the set A, so that's why you have to write IA, that is your identity function. So therefore F inverse OF of X is equal to IA of X, which implies that F inverse OF is equal to IA. Is that clear? So now, since F is onto function, therefore F inverse is also onto. Therefore, again, हामीले say Y belongs to the set B. There exists for each. So let us write here. For each Y belongs to the set B, there exists X belongs to the set A such that F of X is equal to Y. Okay, that is X is equal to F inverse Y. Is that clear? Now we will prove this relation. F OF inverse is equal to IB. Okay. So now let us prove it now. So therefore F OF inverse of Y, which is equal to, it is defined as F of within bracket F inverse Y, which is equal to f of, what is f inverse y? It is x. So what is f of x here? Y, which is equal to y means iby. Y means iby, right? So next, so which implies that f of f inverse y is equal to iby. Is that clear? From both the sides, it is just like cancelling y from both the sides. What does it imply? F of f inverse is equal to IB. So we have proved both this relation. F inverse OF is equal to IA and F of f inverse is equal to IB. So hence what can you write? F inverse is equal to F. So it is proved. So I think you have understood it. So you can copy it. Now we'll do the next theorem. That is theorem number 5. Okay. So now we'll do the next theorem, that is theorem number 5. So theorem number 5 is, let the function f such that a to b and the function g such that b to c be 1 1 onto functions. So both these functions are 1 1 onto function, that is f such that a to b is 1 1 onto function and also g such that b to c is also 1 1 onto function. So you have to prove that GOF, that is composition of these two functions f and g, that is GOF such that a to c is also 1 1 onto function. You have to prove it, and also you have to prove that GOF inverse is equal to f inverse o g inverse. You have to prove LHS is equal to RHS. Okay. Now let us prove that GOF is 1 1 function. So here it is given that here given is f such that a to b is 1 1 onto 1 1 onto. Also g such that a to b is not a to b, this is b to c. B to c is also 1 1 onto, is 1 1 onto. Now we have to prove that, first of all you have to prove that GOF is 1 1. Pahila GOF 1 1 bhaner prove garu. Then we can prove GOF as onto function. Okay. So we have let us take two values x1 comma x2 which belongs to the domain A. So we have GOF of x1 is equal to GOF of x2. So it should imply that in order to prove that GOF as 1 1 function, you should prove here x1 is equal to x2. Okay. So which implies that GOF of x1 is defined as g of f of x1 is equal to, this is defined as g of f of x2. Is that clear? So अब हामी यो f of x1 र f of x2 लाई x1 x2 लिनु सक्छौं. जस्तै यहाँ g of x1 is equal to g of x2 भरि हामीले यो f of x1 लाई नै x1 suppose गर्यौं, f of x2 लाई x2 suppose. Just try to understand it only. Don't write it. This one. This is the rough part. You have to write this part only, not this part. Okay? This is just the rough work. Try to understand it. Suppose हामीले f of x1 र f of x2 मा respectively x1 र x2 लगायौं भने, तर यहाँ g is 1 1 भन्दैछ. क्वेशनले दिएको छ this g is 1 1 function. So it implies that x1 is equal to x2. Similarly, instead of x1 there is f of x1, instead of x2 there is f of x2. So what does it imply? F of x1 is equal to f of x2. What is the reason behind it? Since g is 1 1. Since g is 1 1 function. Okay? So which implies that again, since f is 1 1 function, you can write x1 is equal to x2. Since f is 1 1. Since f is 1 1. So I think I've understood it. So we can write here, therefore this golf of x1 is equal to golf of x2 implies that x1 is equal to x2. What does it indicate? What does it indicate? Golf is also 1-1 function. So golf is 1-1 function. So golf is 1-1 function. So I think you have understood it. Okay. Now we have to prove that golf is onto function. You have to prove that golf is what? Onto function. Okay. So now here, since z such that b to c is onto function, therefore what can you write? Therefore for each z belongs to the set C, there exists y belongs to the set B such that z of y is equal to z. Since z such that b to c is onto function, so what can you write? Therefore for each z belongs to the set C, there exists y belongs to the set B such that g of y is equal to z. I think you have understood it. Again, what will you write here? Again, if such that a to b is onto function, right? Again, if such that a to b is onto function, therefore for each y belongs to the set B, there exists x belongs to the set A such that what can you write? F of x is equal to y. Such that f of x is equal to y. So I think you have understood it. So this is from the definition of onto function. Now we have to prove that golf is onto function. अब हामी golf onto function भनेर prove गर्नु पर्यो हैन? So let us prove it now. Golf as onto function. So therefore golf of x. So let us find out golf of x first. So it is defined as z of f of x, which is equal to what is g of f of x? What is f of x here? Y. Z of, instead of f of x you can write y here. What is g of y? G of y is z. So therefore we have proved that golf of x is equal to z. Golf of x is what? It is z. Okay. So this indicates that, what does it imply? Therefore z belongs to the set C. So z belongs to the set C implies that z, so here you can write, for each z belongs to the set C, there exists x belongs to the set A such that golf of x is equal to z. Such that golf of x is equal to z. Is that clear? For each z belongs to the set C, there exists small x belongs to the set A such that golf of x is equal to z. Okay. So therefore golf is onto function. So therefore golf is onto function. Therefore golf is onto function. So I think you have understood it. Okay. So next, what will you write now? So we have proved that golf is 1-1 as well as onto. So hence golf such that A to C is 1-1 onto. So I think you have understood it. So we have proved the first part. Now you will prove that golf inverse that is GOF inverse is equal to F inverse OG inverse, right? So as you know that F of X is equal to Y, that is F inverse Y is equal to X, that is F inverse Y is equal to X, right? Again we have G of Y is equal to Z, Z of Y is equal to Z, so G inverse Z, Z inverse Z is equal to what? It is Y. So I think I've understood it. And also we have GOF of X is equal to GOF of X is equal to Z. Also we have GOF of X is equal to Z, right? So now let us prove it now. Let us prove this second part. GOF inverse is equal to F inverse OG inverse, right? So now F inverse OG inverse, F inverse OG inverse, let us write here Z. Let us write here Z. Okay, so which is equal to, it is defined as what? F inverse within bracket G inverse Z. Is that clear? This is your inverse, right? Not dash. This is your inverse. So which is equal to F inverse, what is G inverse Z? It is Y. It is Y, right? So which is equal to, what is F inverse Y? What is F inverse Y? It is X. This is your X. This is your X. Okay? So now in this case, यहाँबाट हामी के बुझ्छौं भन्दाखेरि त f of x is equal to y छ भने x is equal to कति भयो? f लाई उता लादा f inverse y भयो. That is f लाई उता लादा f inverse भइगयो. Similarly g of y is equal to z. That means y is equal to g लाई उता लादा के भयो? g inverse z भइगयो. Similarly here also GOF लाई उता लादा के भएर जान्छ? GOF inverse, this is GOF inverse z is equal to x, isn't it? Is that understood? यो GOF लाई हामीले उता लादा के भएर जान्छ? GOF inverse z is equal to x. Is that clear? So f inverse y भनेको कति आयो यहाँ? x आयो. So instead of x, what can we put? GOF inverse z. This is GOF inverse z. तो यो चाहिँ के भ्यालु भयो भन्दाखेरि f inverse OG inverse of z is equal to GOF inverse z. So therefore GOF inverse z is equal to, we have proved that f inverse OG inverse g inverse of z. Clear? So from both the sides it is just like cancelling z here. So what do we get? This is GOF inverse is equal to AF inverse OG inverse. So it is proved. So I think you have understood it. So we have proved that GOF inverse is equal to F inverse OG inverse. So it is proved. Okay. So you can copy it. So try to understand it. So today we did problems from higher secondary question papers, and then we did invertible functions, and we did the definition of invertible functions, what is meant by invertible functions, and we did some theorem relating to invertible functions. So you revise all these theorems and problems at home. So this is your homework. So in the next online class we will do problems on these invertible functions. The next online class को लागि चाहिँ तिमीलाई यो सबै थाहा हुनुपर्छ theoremsहरु. जति पनि आज हामीले theoremsहरु गरेका छौं, यो theorems तिमीले घरमा राम्रोसँग रिभिजन गर्नु. Try to understand it, try to analyze it. Okay? त जति पनि यहाँ नोटेसन्सहरु हामीले लेखेका छौं, त्यो नोटेसन्सहरु सबै याद गर्ने कोसिस गर्नु. ठीक छ? त नेक्स्ट अनलाइन क्लासमा चाहिँ हामी यही इन्भर्टिबल फंक्शन्समा हामी के गर्छौं? प्रब्लम्सहरु गर्ने छौं. त त्यसको लागि चाहिँ यो थ्योरमहरु याद हुनै पर्छ. ठीक छ? So this much is for today.